Now we will learn about a shortcut to these dihybrid crosses, and instead of having a Punnett square with 16 boxes, we will have 2 Punnett squares, each with 4 boxes. We'll apply the product rule or the rule of multiplication, and here we'll see that 4 times 4 is 16, so we will be able to do 2 monohybrid crosses and get the same result for a dihybrid. But first, let's apply this rule, this product rule, to a simple coin flip. What we're looking at here is flipping a coin and getting heads up 2 times in a row. What are the chances of that happening? Well, since flipping a coin is an independent event, and each time you flip, it has 50% chance or 1 out of 2 chances of getting heads up, and you're doing that 2 times, 1/2 times 1/2 gives us 1/4 or 25% chance of flipping heads up 2 times in a row. So we're going to apply this rule of multiplication to dihybrid crosses and make 2 Punnett squares. I'm going to go ahead and use the cross from the previous example where we were heterozygous for the length of the stem, and we were also heterozygous for the flower color. And that was true for both parents. And now I'm just going to do 2 monohybrid crosses, 1 for each trait. So I'll do a monohybrid cross for just stem color, or stem length rather, and I will do a monohybrid cross for the flower color. Okay? And that means that I'm going to only be using L's over here and the F's over here. Okay, I'm not going to mix up my F's and my L's. So I'll have the first parent being heterozygous across the top and the second parent being heterozygous across the sides. And then shuffle in the L's into the Punnett square. I'll do the same thing for my F's for the flower color, heterozygous for flower color across the top and the side, and then shuffle in the F's into the Punnett square, showing the possible combinations of alleles in the offspring. Okay, so now we can figure out what the phenotype ratio is. The phenotype ratio, as you can remember, is dominant-dominant, dominant-recessive, recessive-dominant, and recessive-recessive. And we're talking about having dominant for both traits, dominant for one and recessive for the other, for the 2 middle parts, and then recessive for both traits. So let's do the rule of multiplication and figure out the phenotypic ratio. First, dominant-dominant. How many out of 4 are going to be have at least 1 capital L? I see 1, 2, 3. 3 out of 4 have at least 1 capital L. How many out of 4 have at least 1 capital F? 1, 2, 3. Now we're going to apply multiplication. 3 times 3 is 9. So we have 9 out of 16 chances of having a flower that has a long stem and a purple flower. We're going to do the same thing for the long stem and white flower. So we're looking for at least 1 capital L and lowercase f. So we have 1, 2, 3 capital L's and 1 lowercase f. So 3 times 1 is going to give us 3. So we'll have 3 out of 16 chance. Next, we'll do short stem, so 2 lowercase L's, and purple flower, all capital F's. So we have 1 out of 4 is going to have a short stem. And how many out of 4 are going to have at least 1 capital F or purple flower? 1, 2, 3. So 1 times 3 gives me 3. So I will have 3 out of 16 chance of having a short stem with a purple flower. And lastly, we're talking about short stem and white flower. So recessive for everything. And it looks like we just have 1 here and 1 here. So 1 times 1 gives me 1. So the phenotype ratio for this cross is 9 to 3 to 3 to 1, just as we saw when we did the full dihybrid cross with all 16. Try these for the problems on the second page.